Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology. So today we are going to discuss about the clippers. So let us have a small recap about the previous session. In the previous session, we discussed wave shaping circuits. The wave shaping circuits are the electronic circuits that is mainly used to modify the input waveform into the desired output shapes. For example, in the last video session, we studied integrator, differentiator, different types of wave shaping circuits, that is integrator and differentiator. The integrator circuit, wave shaping circuits are used to convert the input signal, that is the square waveform into triangle waveform by accumulating the input signal. And then the differentiator is also a wave shaping circuit that converts the square waveform into the spikes by changing the that is by recording the rapid changes of the input signal. So let us move on to the today's topic. So in this video session, we are going to cover that is the empathy of the clipper. That is why we need clipper, what is a clipper circuit, and different types of clipper circuits. So let us move on to the topic. First, we should know why we need this clipper. So the clipper circuit, that is one of the wave shaping circuit, is mainly used for noise reduction and signal protection. So it is mainly used to limit the signal voltage to a fixed level. Also, the main need of this circuit is it protects the circuits from high voltage damage. It is mainly used in analyzing the electronic circuits and communication systems and in medical equipments. For example, in medical equipments, we need example ECG and EEG is mainly used to give the waveforms of as about the heart rate of the heart signals of the patient. And in mobile charging, it is used to convert AC into DC. And in communication systems and other electronic circuits, it is mainly used to generate different types of waveforms, the different types of waveforms like a square waveform, sine waveform, and a triangle waveform. And it is mainly used to generate timing and clock signals, that is square waveform. So these are the needs of clippers. So with these points, with these empathy points, we can define clipper. That is, the clipper is a electronic circuit that produces the output by removing a part of the input above or below the reference level. That is, the output will be the same as that of the input for other than the clipped part. So because of this, the peak to peak amplitude of the output of a clipper will always less than the input. That is because of one side is clipped based on the reference voltage. So the main advantage of a clipper is that they eliminate the unwanted noise present in the signal. So this is the definition of clipper. So there are many ideate portions. Suppose if you want to remove positive cycle of the waveform, or if you want to remove negative cycle of the waveform. So based on this, the clipper can be classified into two types: positive clipper and negative clipper. And this is the circuit of positive clipper. So the first thing I want to share that the clipper circuit consists operational amplifier, because clipper and is the one of the application of the operational amplifier. So there are two types of clipper. So the clipper circuit mainly consists of operational amplifier and diode and some resistors. As we know that operational amplifier has the three terminals, that is inverting terminal, non-inverting terminal and the output terminal, and plus VCC and minus VCC are the supplies. And here the resistors R1 and here the resistors R1 and R2 are used to set the reference voltage, and in the inverting terminal the output is given to the inverting terminal, and diode that is the diode D1 is connected here, that is in the output side. So this is the circuit of the clipper, and the main thing is positive. For the positive clipper, the diode, the output of the this is this is cathode, and this side is anode. The output is directly connected to the cathode side for positive clipper. And the main principle of the clipper is, if the input is less than, if the input voltage, that is input signal VI, that is VI, the VI is less than the reference voltage, it clips the positive side of that. For in the that is the diode conducts and clips the that is removes the unwanted portions in the positive side. And for the that is D1 conducts, the circuit behaves as a voltage follower, and this is the input and output waveform, that is this is the input waveform for the positive clipper, and so the above the reference voltage it is clipped. This portion is clipped. From this portion is clipped in the that is in the positive side. And this is the circuit of the negative clipper. Again, the operational amplifier, and that is a diode. That is diode, and R1 R2 is used to set the reference voltage, and here the diode is connected in the opposite direction as seen in the positive clipper. Here also the same working principle works. So the operation of a negative clipper circuit, that is, if the value of the input voltage is greater than the value of the reference voltage, then the D1 conducts. So the above circuit behaves as a voltage follower, and in negative clipper, the negative portion of the input is clipped. Here, see, this is the input, and here the negative side is clipped. The negative side is clipped. So this is the input and output waveforms of clipper and clamper. That is, the clipper is one of the operational amplifier application. Hope this video will help you to understand what is wave shaping circuits and the different types of wave shaping circuits, and what is the need of clipper circuit, and what is meant by clipper, and what are the different types of clippers. Thank you.